Chapter 5, Section 6, Question 1. There are many ways to do this problem. However, I'm going to tell you that I'm going to show you a way that is 9 steps. It is longer than normal, but it has protected many people's grades. And it uses U-Substitution, which is going to prepare you better for your college class. Here, I don't have a U. What I really have is I have a U squared is equal to 4x plus 3 squared, which would mean that U would just equal 4x plus 3. But I don't have a 4x plus 3 term. This is going to be a difference of squares. Notice that it doesn't say sum or difference of squares, only difference of squares work. So I'm going to write this as 25 minus U squared. Well, that's not written in descending order by degree. So to write in descending order by degree, I need to move this term to the front. But wait, I now have a leading negative. And we have learned that, at least in our textbook, if you have a leading negative and it says to factor, you have to factor out that leading negative. There is our difference of squares, something squared minus something squared. This is a section on cool factoring tricks. And what it means is that we can factor this almost without thinking about it. U squared will break up as U and U. And 25 can break up as 1 and 25 or 5 and 5. But what's going to happen is on this, it's going to break up into the ones where the two numbers are the same. And to get a minus here, I need 1 to be positive and 1 to be negative. But that's not our answer. We need to have it back using x's. So you don't get credit for that. That's just to help you figure out what this answer is. It is negative RU, which was 4x plus 3 plus 5, and a 4x plus 3 with a minus 5. Combining like terms, we get 4x plus 8 and 4x minus 2. And you would think you were done, but then you think, wait, evil math teachers. And you say, oh no, I can pull a 4 from this and be left with x plus 2. And then you think, but wait, I can take out a 2 from this. Notice if it was a negative 2, I'd have to put parentheses around this. And I would get 2x minus 1. And then, by their powers combined, that 2 and that minus 4 become negative 8. And then we have monomials first, binomials second. Wow! That is actually longer than a normal problem because on the lecture I want it to be as difficult as possible so that if I give you something that is much nicer, that you can handle it. So U-substitution to help us break that up. Some students know that they want to switch the order on this, so they take out a negative. The 4x plus 3 goes here and here. The 25 breaks up as a positive and a negative. They combine like terms. So really, half credit. Any of these half credit, and then full credit. Sometimes when you get to this, you're actually done because there are no evil math teachers. And we will have to sneak that in there somewhere because we'll have to sneak that in somewhere. Chapter 5, Section 6, Question 2. The lecture notes have the problem done just with decimals, but I changed every single decimal into its corresponding fraction. I'm going to do it both ways to show you that it doesn't really matter. I actually think that the fractions are easier, which is why the decimals are in the lecture notes, but some students had some questions on this, so I put that in there. All right. This is a perfect square trinomial, and we are in Chapter 5, Section 6, which is special factoring formulas, which means the problems in this section are magic. They're going to be very easy to solve. You're going to look here, you're going to look here, you're going to look here, and you're going to break it up very nicely. 9 breaks up as 3 times 3. And you'll remember from Chapter 1 that if you have 2 decimals here, we'll have 1 decimal in each of these. And we should have the 0 in the front of the decimal. C squared breaks up nicely as C times C. The symbol you'll use is a negative on both of them. 16 breaks up as 4 times 4. 2 decimals here, so 1 decimal in each of these with a 0 in the front. You'll notice that I just wrote the same thing twice, which means that while sometimes I run it this way, by the time we get to chapter 7, we'll actually have to write it this way. I'd like you to get started writing it this way. I would probably not take off points at this level of math if you're writing it this way. We'll still need it written like this for chapter 6, but by chapter 7 we'll have to write it like that. All right, we also have this one. You'll look here, here, and here. I know I'm going to have to write it as something squared, so I'm going to start off that way. 9 breaks up as 3 times 3, 100 breaks up as 10 times 10, c squared breaks up as c, that's a minus. 4 is 2 times 2, and 25 is 5 times 5, and we're done. 3/10. 3/10. 2/5 is also equivalent to 4/10. 4/10. It's the same answer. I think fractions are actually easier. Chapter 5, Section 6, Question 3, Introduction, Factoring Cubics. Often, students will look at this and break it up like this, and that's wrong. I wanted to show you visually that they are wrong by having you take out your graphing calculator, hit y equals, I'm going to clear out anything else that's in there. For y1, I'm going to put in 8x, which is next to the alpha button, cubed. I can do up in the corner 3, or I can do math 3. So up in the corner is a 3, 8 cubed. Because I have the newer operating system, I have to hit the right arrow to make it back down to regular size, plus 27. Down arrow to get to the next one. So under y2, I'm going to put parentheses, 2x plus 3 parentheses, and this time I'll do math 3, which will be cubed as well. So I have this equation and this one. I'm going to graph them both. And as I graph them, I notice that they're different. So the graph of it, one of them just kind of goes up this way, and the other one kind of goes this way. They're different from each other, which is why these are not equal to each other. And I wanted you to know they are not the same, which is why no credit will be given. If I see you write this at all on your paper, oh, that's just how I'm thinking about it. No, this is wrong. I will mark your entire problem wrong because this is wrong. Chapter 5, Section 6, Question 3, the real one. Now, we just went over how not to factor it. We're going to find out how to factor it. We're supposed to make perfect cubes, and this is not a perfect cube, and that is not a perfect cube. Just the a cubed is a perfect cube. What went wrong? Remember that the first thing we taught you is the first thing you forget, a GCF. These are both divisible by 3. So if we factor out of 3, we'll get a cubed, which is a perfect cubed, and 27, which is a perfect cubed. So this is factoring out your GCF. And now, I had a student who did this, a couple of students, and they did a times a times a, and 27 breaks up into 3 times 3 times 3. That actually saved them a step, so I'll take it. In the first parentheses, we're going to use SOAP, same, opposite, always positive. The first one, we're going to take 1a and 1, 3. And use the same sign, which is minus. Then we're going to take these two a's, and a times a gives me a squared. The opposite sign, the middle term is a times 3, which is 3a, number first, variable second, always positive, and then the last term is 3 times 3, which is 9. Make sure that this coefficient here, the greatest common factor, make sure it comes down to your answer. Chapter 5, Section 6, Question 4. We have factoring the sum and difference of cubes. We were just factoring the sum or difference of cubes, but this time we have a picture. Now, this says sum, but you know from previous problems that we could also use the word difference. Sum would mean adding, difference would mean subtracting. It says I want 2 lines of work. So the first line, we're going to use the volume formula. The volume is length times width times height. In this case, they're all the same. So you're going to take 3m times 3m times 3m, which is 3m cubed, have the sum, add it to n times n, which is n cubed. This is a perfectly fine first line. However, some students are going to want to take this and multiply it together. So if you would like to write 27m cubed plus n cubed, that's fine, but all you're going to do with this is break it apart again. So this is fine. Here, we're going to take this, and if you remember from before, we're going to break this up into 3m, 3m, and 3m, and break this up into n, n, and n. The first is going to be a binomial using same. So one of these and one of those. 3m, same sign plus n. Then for the binomial, finishing off so same opposite always positive, we're going to use 3m times 3m, which is 9m squared. Opposite sign minus 3m times n, 3mn. Remember, alphabetical order, always positive. And then last but not least, we have n squared. And you might think that you are done, but this is a picture problem. We're going to have to label it. We're talking about volumes. Remember, volumes are going to get units cubed. Areas will get units squared. And everything else will get units regular. This is a volume, so we want our V equals, and we want our units cubed. We don't need the SOAP letters underneath. We don't need these either. So really what we need to see is this part here and this part here. Half credit, full credit. Chapter 5, Section 6, Question 5, Type 1 of 3. In Section 5, or in Chapter 5, Section 6, we learned about difference of squares, perfect square trinomials, and factoring sum and difference of cubes. This is a difference of squares. You'll notice that this is a perfect square. 4 breaks up nicely into 2 pieces. 49 is a perfect square, and 6 breaks up nicely into 2 pieces. Let's take a look at that a little more closely. 5 times 5 gives you 25, and x to the 2m. If I squared each of those, that's how I would get that. And 7x to the 3n. If I squared both of those, I would get that. So the way we do a difference of squares, we do not actually need this, but it would break up as 5x to the 2m, one version plus 7x to the 3n, and then one version with 5x to the 2m minus 7x to the 3n. And that is our answer. One version with plus, one version with minus. A quick thing to remind you about that is the difference of squares is going to be something like x squared minus 9. And many students know that that breaks up into x plus 3, x minus 3. Because x times x gives you x squared, 3 times 3 gives you 9. And when you have this, you'll have one positive, one negative. Chapter 5, Section 6, Question 5, Type 2 of 3. So on the last slide, we did a difference of squares. This is a perfect square trinomial. And remember that we can look here, here, and here. This is only pretty much guaranteed in Chapter 5, Section 6, because this is special factoring formulas. This is a special factoring formula. Otherwise, you would actually have to double check it. Remember that this is going to give us something squared. So we're going to break this up. There were a to the 2n, so when we break it up, it'll be a to the 1n. This is the symbol that goes in the middle. 9 breaks up as 3. B to the 2m will break up as b to the 1m. And that is our answer. Chapter 5, Section 6, Question 5, Type 3 of 3. We've already done difference of squares. We have already done a perfect square trinomial. Obviously, the last thing is going to be a sum or difference of cubes. In this case, I have a sum of cubes. If it helps you, break it up into what got cubed and what got cubed. You do not have to do this, but here, 64 breaks up into 4, 4, and 4. X to the 3m breaks up into x to the m. And here, 27 breaks up into 3, and 3n breaks up into single n's. This helps us know what goes into our binomial and trinomial. So 4x to the m plus 3y to the n. That's our first one. Now, I showed you with the 3 little things down here and the 3 little things down here. Another student said he looks at it like little arrows and he says this gets multiplied times itself. So he has 4 times 4 is 16, x to the 2m. Then he takes this and multiplies it times this. We're using SOAP again, and we get 12, x to the m, y to the n. Now, take a look at this. Some students write xy to the mn, or xy to the m plus n. These are 2 separate things. The bases are different, the exponents are different. They actually can't go together. And then always positive, he said he now takes this and multiplies it times itself, and we get 9y to the 2n. And that is our answer. Yay! So if doing it this way helps you, hey, there are many ways to make math work.